Basic trigonometric identities and equations. Prerequisite basic knowledge of that tan theta is equal to sine theta over cos theta, and sine square theta plus cos square theta equals to 1. Sketching of graphs, and let's see angles in all four quadrants. So we'll be talking about those angles and their values, magnitude and sine. Once we have the basic angle, it stays same in all the angles and the magnitude stays same. For example, if I write sine 30 and this is sine 30 degrees, let me check the value. So sine 30 is 1 by 2, 0.5. So I know that sine 30 is 0.5, and taking the basic angle as 30 degrees in all four quadrants. I now know what the angles would be. First angle is sine 30. That's right here. Second is 150. So sine of 150. Third is 180 plus 30. That is sine 210. And last is 30 less than 360, which would be sine 330. So I've already checked the value of sine 30, which is 0.5. So all of these four will have 0.5, but with a difference in sign. And what would that difference be? We know that first quadrant is add sugar to coffee, or some like to say adds. So first is positive for sine, second is positive for sine, and the remaining two are negative. Okay, write down the values of sine 90. So we can do it two ways. One is the sketching, the other is using calculator. That depends on the demand of the question. So for example, we are talking about sine theta. This is the general graph of sine theta, which starts at 0. The highest point is 1. The lowest point is -1. And the graphs end at 360 for sine theta. The curve completes in 360. So once we divide it equally, we know that sine 90 is 1 and sine 270 is -1. So sine 90 is equals to 1. Sine 180 from the same graph, you can see that is equal to 0. When we talk about sine pi by 2, if we change all of these scales in radians, this is 2 pi, this is pi, this is pi by 2, this is 3 by 2 pi. So basically sine 3 by 2 pi is equivalent to 270, which is -1. Now sine negative pi by 2, we can continue the same graph on the other end. This is sine on this side, and you can continue the same graph on the opposite side. This was pi, this is pi by 2. Now this is minus pi, and this is minus pi by 2. So minus pi by 2 is equivalent to -1. Write down the values of tan 45, tan 135, and so on. Okay. Now we have two triangles also. Other than graphs, we can discuss these in triangles. Let me quickly just draw the graph of cos and tan also before we move on. So this is 2 pi or 360. This is pi. This is pi by 2. This is 3 by 2 pi. Maximum value is 1. Minimum value is -1. The graph is for cos theta. When we talk about tan theta, we divide them into equal 4 parts, 1, 2, 3 and 4, and draw vertical asymptotes at these two intervals, first and third. So this is 360, that is 270, this is 180, and this is 90. Now we'll go draw the graph. It comes near this line and gets as vertical as it could, but never touches the line. So this graph is for tan theta. Amplitude doesn't matter here. And now the two triangles to answer for like 30 degrees, 45 degrees, 60 degrees. So we draw this first square of side 1 each, and I'm drawing this diagonal and extracting the required triangle on the other side. So you see that was a square with side 1 each, and drawing the diagonal made it 45 degrees. Now applying Pythagoras theorem, we can find this side as square root 2. Another triangle is equilateral triangle of side 2. So we know these are 2 and all the angles are 60 degree. So if you draw the vertical line and split it into 2 and bring one of the triangle on the other side, so this is now 1 as we split it up vertically. This was still 2. This angle is 60. The angle at the top is 30. Applying Pythagoras theorem, we get square root 3. So we can answer some values from these two triangles, like tan 30. I can see 30 perpendicular over base is 1 by square root 3. Tan 60 at angle 60 perpendicular over base is square root 3 by 1. Tan of 45 from the first triangle is 1 by 1. So we can answer multiple questions using these two triangles. Now about this tan 135 and tan 225. So we should know what the basic angle is. One is tan 135, the other is tan 225. So if I could sketch it, I know that 135 would lie in the second quadrant. If this is 135, this angle right here should be 180 minus 135, which is 45 degrees. So tan 135, and we know add sugar to coffee, and we know that tan 35 here is negative actually. So I can write tan of 135 is equal to negative tan of 45, because 45 is the basic angle. We will have the same magnitude but sign is different. So negative and 45 from that triangle is 1. So I'm writing minus 1 here. Now about tan 225. Tan 225 is more than 180 and less than 270. So it lies in the third quadrant. And if it is 225, I'm finding this difference. So 225 minus 180 gives me 45. I already know what tan 45 is, that is 1. But add sugar to coffee, that is positive this time. So I can write that tan 225 is equals to tan 45, because both have the same basic angle and both are positive. So my answer is 1. Same goes with those angles in a radian form. Now this tan pi is actually tan 180. We've just sketched the graph, and let's see, tan 180 is 0. That means tan pi is 0. Same goes for the remaining parts. We've discussed the quadrants. Did you ask something? Okay. This is the same thing we discussed earlier. 360 minus theta, first is theta, then 180 minus theta, then 180 plus theta, and last is 360 minus theta. It says express in terms of trigonometric ratios of acute angles. So cos 330, a quick sketch, it lies here. This is the acute angle. So 360 minus 330, this is cos 30. Now be careful, cos 330 is in the last quadrant, which is positive, and cos 30 is positive, so that's fine. When we talk about sine negative 100, we always move in clockwise direction. This negative indicates we move in anti-clockwise direction. This negative indicates we have to move in clockwise direction. So 100 will bring it here. So sine of negative 100, now see, this is in the third quadrant, and which is negative. Now that being 100, the basic angle is 80. The acute angle is 80. So I'm writing sine of 80, and I already knew that sine of negative 100 will give me negative answer, whereas sine 80 lies in the first quadrant, giving me a positive answer. So I have to put this negative sign. Now tan 500, if I see and move around, this is one complete circle of 360. So 500 minus 360, I know that it is 140 more. So more 140, when I reach here, this is the point. And if it is 140, the remaining angle is 40. So the basic angle, acute angle, is tan of 40. But tan 500, we know that it led us to the second quadrant. So add sugar to coffee. Tan 500 would have been a negative value being in the second quadrant. So I'll write a negative sign before that. So I can say tan 500 is equal to negative tan 40, because both have the same magnitude, having the same basic angle, but we have to adjust the positive negative sign. Now if I look at this, sine 2 by 3 pi. So this is one complete pi, 180 degree. So 2 by 3 is actually in the second quadrant. So if this is 2 by 3 pi, we can find this remaining part, that is pi minus 2 by 3 pi, giving us pi by 3. And sine is positive in both these. So I can write sine 2 by 3 pi, 2 by 3 is obtuse. Converting it into acute angle is sine pi by 3, and both are already positive. Exercise 6a. Draw diagrams to show the following angles marked in acute angles and that OP makes with x-axis. So this is minus 80. We mark it here, and this is negative 80. This is 100. So we move anti-clockwise, and this angle is 100. And in the same way, all the other angles. Let's try this H part. That is 11 by 6 pi. I'm checking what 11 by 6 makes. 11 by 6 is 1.8 pi. And this complete circle is 2 pi. So it led me here in the third quadrant. And this is 11 by 6 pi. And it said mark the acute angle as well. So this was 80, and in this case complete is 2 pi. So 2 minus 11 by 6, I'm left with 1 by 6. So I should mark this acute angle as 1 by 6 pi, or pi by 6. Question 2 says state the quadrant that OP lies in when the angle OP makes with the positive x-axis. So 400. One complete circle is 360, and the difference between 360 and 400 is 40 degrees. So we move 40 degrees more. It lies in the first quadrant. State the quadrant, that is the first one. 115, clearly second one. Negative 210. So negative 210, we are moving clockwise. 0, minus 90, minus 180, and somewhere here, because more towards the vertical line would be 270. So it is again in the second quadrant. Now 5 by 4 pi. We already know that pi is a straight line. So it is more than pi. and 5 by 4 is 1.25, whereas 270 is 1.5, so it is somewhere here. So the quadrant is third quadrant. Now 5 by 9, 5 divided by 9 is actually 0.55, which is more than 0.5. This was 0, this was pi by 2, making it 0.5 pi and 5. So 0.55 is more than that, so it led us to second quadrant. Now without using calculator, write the values of. So we already know what sine 90 is, and we can use our graphs. So I'm looking at this triangle, this graph. This is 90 and sine minus 90 is minus 1. So equal to minus 1. We can answer all of these using either our graphs or those two triangles. Now this is sine 450. I should know the basic angle first. So I'm subtracting 360 and I'm getting 90 degrees. So that is equal to sine 90, which is 1. 540. Now 540 minus 360 gives me 180. And sine 180 is 0. I'm answering this from the graph. Minus 450. Now 450 and minus 450 are opposite. This is minus 1. Cos of negative 180. This is cos. Positive 180 gives me negative 1. Negative 180 gives me negative 1. So we have to be confident in sketching and the two triangles. Question 4. Express the following in terms of trigonometric ratios of acute angles. So it is more or less the same. 240. I'm saying where it leads, it is already in the third quadrant. 240 is right here. So I'm looking at the difference between 180 and 240, and the difference is 60 degrees. So I'm writing sine 60, but I need to consider 240 when in third quadrant sine is negative. So I need to put a negative mark before this. So that is negative sine 60. Now sine of negative 80, which is already in the fourth quadrant, express the following trigonometric ratios of acute angles. So that is negative 80, acute angle, that is already acute but negative, so I'll write it as 80. Now add sugar to coffee. This was giving me negative value, so sine 80, which is obviously a positive value, I'll put a negative sign before this. Tan 100, this is at this point in tan 100 must be negative. Acute angle is 80, so we're going to write tan of 80, and we know tan 100 is negative, tan 80 is positive, so we'll put a negative sign ourselves. And in the same way, all the other questions. Prove that sine 180 minus theta is equals to sine theta. So we've been already discussing this. For example, let's say these are the two angles. Let me say this is x. I'm deliberately writing x in place of theta. So this should be x again. And we know both of these have same signs because add sugar. Both are same basic angles and both are in first and second quadrant. So for the first angle, I can write sine x, and I know this second angle is also equal. So I can write sine 180 minus x. Done with the first one. Now look at the second one. Prove that cos of negative theta is actually equal to cos of theta. So let's say cos theta is here and negative would push me in the clockwise direction, negative theta. So add sugar to coffee. Now the basic angle is already same, and the first one is positive, the second one is also positive. So when the angle is same and the magnitude is same and both are positive, so that's equal. Same goes for tan. Now pi is actually working as 180 degrees. So if we are talking about tan theta, now that is, let me say this is tan theta. So this should be tan theta and positive and acute, but in the question that is there is a negative sign. So keep in mind this thing in the square is positive, that negative sign makes it negative. Now pi minus theta. Pi minus theta is bringing me here. Pi minus theta, because this is the basic angle. So tan pi minus theta, or I say 180 minus theta, is obviously in the second quadrant, which itself is already negative. So makes sense that these two are equal in magnitude, and this adjustment of sign make them two equal to each other and balanced. Exact values of trigonometric ratios indirectly covered these two triangles before. So if it says find the exact value of sine negative 210, we know that we have to move clockwise. This is 210, and the difference between 210 and 180 is 30. So 30 degrees, I'm going to that triangle, and sine 30 is perpendicular over hypotenuse, which is 1 by 2. So negative 210 is equals to 1 by 2, and I already know I am in the second quadrant, and the answer should be positive 1 by 2, which is already written. Let's say we talk about this tan 300 and tan minus 225. So first this tan 300. Clockwise, this brings me here. More than 270, less than 360. So this is 300. The remaining angle should be 60. So I know add sugar to coffee. I'm going to check tan 60. In the first triangle, tan 60 is square root 3 by 1. That is square root 3. So tan 60 and tan 300, I'm writing square root 3. But I know that is in the fourth quadrant. So I need to put a negative sign. So tan 300 is actually negative square root 3. Now on this high part, tan negative 225. Negative 225 brings me in this quadrant, and the difference between 225 and 180 is 45. So we go back to our triangle. We have to memorize this triangle, remember that. So 45 is perpendicular over base, that is 1 by 1, already 1. So tan 225, I'm writing the value 1, but I know that it is in the second quadrant, so that needs to be negative. Any confusion? Okay. Now using these two identities, sine square theta plus cos square theta equal to 1, and tan theta equals sine theta over cos theta. Let's see what the questions are. It says simplify the following. So if I simplify these two, that is sine square theta plus cos square theta, I'm writing it directly equal to 1, considering these two the same angles and using the identity. Now this says 5 minus 5 sine square theta, and we remember the identity cos square theta plus sine square theta is equal to 1. Actually the resultant form is not given, so we can switch them with whatever we wish. So if I just substitute the sine square as 1 minus cos square theta, we can substitute and simplify. Look at this example 7, identity cos raised to the power 4 theta minus sine raised to power 4 theta divided by cos square theta, and on the right hand side 1 minus tan square theta. So we will rearrange these and use identities to prove that left hand side is equal to right hand side. So if I just write it this way, like cos square theta whole square minus sine square theta whole square, does it make any difference? This was 4, is it still 4? This was sine 4, is it still 4? So this actually made it look like a square minus b square, which would be a plus b into a minus b. So a is cos square, a plus b into a minus b. Now we already know that cos square theta plus sin square theta could be written as 1. So that disappears. We are left with cos square minus sin square over cos square theta. Now you split these two. So cos over cos is 1 and sin square over cos square. If tan theta was equal to sin theta over cos theta, so squaring both sides could be sin square over cos square equals tan square. So proved that left hand side is equal to the right hand side. Now see, given that cos theta is negative 3 by 5, we will deal with these signs later. First I'm sketching this triangle. If this is theta, this says cos theta is 3 by 5, so this should be 3, this should be 5. And when we apply Pythagoras theorem to this, I get this side as 4. Now he's saying that cos theta equals negative 3 by 5, one thing. So we know where cos is negative in the second and third quadrant. But it says it is a reflex angle, so it should be more than 180, which made it sure that it is confirmed in the third quadrant. Now he's asking about sin theta. So sin theta, from the triangle I can see that sin theta is 4 by 5, and from this quadrant diagram I can see it is in the third quadrant, so it should be negative. So when cos theta is equal to negative 3 by 5 and theta is a reflex, sin theta is minus 4 by 5. Doing the same for question B part. Given that sin alpha is 2 by 5, so let's say this is alpha and sine is perpendicular over base. Solving for this base, applying Pythagoras theorem, that is 5 square minus 2 square whole square root, 25 minus 4, so that is square root 21. Square root 21. As far as cos alpha is concerned, cos of alpha is equals to base over hypotenuse, that is square root 21 over 5. First thing. Now let us check this sign. Given that sin alpha is 2 by 5 and that alpha is obtuse. Obtuse means more than 90 and less than 180. So it lies in the second quadrant. Sin alpha is 2 by 5. In the second quadrant, that is positive. Alpha is obtuse. But in this case for cos alpha, that should be negative. So my final answer is cos alpha is equal to negative square root 21 by 5. Clear?